Starting up the stream. Looks like the stream is running. Hi everyone, I am TigerHawk3, and today we are going to write some Tetris. So, I think maybe we'll have pieces move somehow, and I think we are going to represent the game board with a 2D list. And once a piece is no longer active, it will be part of the list, or maybe it can just move through the list while it's active. I don't know, but I think a list of some kind. Width, height, square width. Do we have 24 somewhere? Only in a comment. So how about this is the canvas, width and height. And how about we call it board width 10, board height equals 24. Okay. Alright. Board equals we want a 2D list, so we are going to do how about this? Empty string for column in range self.board width for row in range self.board height. This has become a long line, so I'm gonna do that. Okay, that's fine. So we have our board, and now we can actually represent things on the board by just replacing bits and pieces of it with our shape representations. This stuff. So that should be good, I think, so far. I don't know, untested. It's just an idea that I just had, and I'm trying out. That's programming. I have an idea, I think I'll do it. Spawn like this. We enumerate the shape, the rows, so the start is which cell we are putting it into. And that should be, okay, I'm gonna have some print debugging here because I don't want to have an off by one error. So what I'll do is I will go through the shape at some point. We are already enumerating the shape. If column for each row, and we'll do it in the row. And this looks at each cell. This should probably be cell, because we're not talking about an entire column, just one cell. So we have our shape. Do we use this anywhere? Kind of. We will put this on the board. Okay. Go through each row. So for each row, we have, we will say, and y starts at 0. Do we have x yet? Sort of. Start. So we're starting at start. Okay, we have the start and the width. So for y and row and enumerate shape, so we're at the first row and we have the index of it, which is starting with the 0th row because we're just spawning a piece. Let's see. Think. Like Pooh Bear. We're going to say board, and we're going to do a slice replacement. When you have, for example, L 3 5 equals 1 2. That replaces elements 3 and 4 of list L with 1 and 2. And it's the same list L. It's not a new reference. It just assigns multiple elements. It's like doing L3 L4 equals 1 2. You don't need these. It's like that, basically. But you can just use slice notation. So board and we're starting at start. To start plus width. Equals, no, it's a 2D list. Board y start plus width equals shape y. Okay. And then we will print we'll just do this instead of having a weird little generator. Loo for row in board. Print row with a star to unpack it. I feel like trying that, so we're gonna save and we're gonna try that. Okay, and here we go, so we can see what I'm doing, what errors we get. Kaboom! Oops. That is the error we get. I wrote board instead of self.board. That's a pretty simple mistake, easily corrected. Let's try it again. Things happening. So we have our shape over here correctly, and we have our shape in the empty board. Look at that. That's an L shape, and that's the shape we have. And we have this as well. And seems good. I'm going to mark and copy that. And I'm going to start a new file here and paste that in so I can count things. So we have this leftmost block, which is, oh, I can't move this over there. We've got this leftmost block, which is this one. And then we have a space delimiter inserted by the print call. And then we have another block. And then we have, well, that's not right. Oh, it's just trimming it, isn't it? 1, 2, 3, 4. So we have a space, and then delimiter, and then space, and delimiter. Okay. We have space, delimiter, space, delimiter. It kind of stripped white space around. Notice that there's nothing really afterward. It didn't do just a straight up column mode selection. That's okay. Although it is a column mode selector, it strips white space. Anyway, now it is accurate. So we have a space. So that's one space, one empty block, and then the delimiter, and then 2 empty blocks, and then the delimiter, and then our square. So we have 1, 2, I think we need 3, is it? I'm going to take a picture of this and open Paint, and then I'm going to count more easily. We have 1, 2, and not quite enough for 3. Probably, approximately. If I did it more exactly. 1, 2, and pretty much exactly 3. So we have actually 3 of these. What I'm going to do now is I'm going to close that. I'm going to minimize this, and I'm going to close this. Here's what I should have done in the first place. And what I'm going to do is just not unpack it. So we'll run that again, and we get this. Great. And now we get the actual representation of each thing. 1, 2, 3, 4, and a thing. How do I count this? Okay. I'm gonna take a picture of this again. That's fine. And what I'm doing in Paint is just creating other so I'm just copying little regions of a block and pasting more blocks so I can count precisely. So we have 1, 2, 3, 4 empty blocks to the right. Sorry, to the left. 1, and 2, 3, 4. Okay, I think that's correct. And we should have 3, 4. Let's go with 1, 2, 3, 4. 1, 2, 3, 4, 5. So I'm gonna copy and paste this. Looks correct. I'm just checking for off by 1 errors. Okay, I think this is right. The representation in the 2D list is matching the visual board. Cool. Cool beans. Close this. Take out that. All right. Very neat. Very cool. So that's a good step to have. And then when I move something down, I'll check if the row below it is empty. And if it's not, then we settle. And if it is, then we just move it. Sounds reasonable? Okay. All right. Only 16 minutes. I think we will keep going and do more things. So we're gonna bind self.down, self.parent.bind, down. Is this the down arrow? I think. I'm not entirely sure. Let me look that up on fbot. Bind. What are the bindings? Events and bindings. Is there a list? Here we are. Return. Special keys. Page up and down. Left, up, right, down. Okay. So, yeah, it is simply down to do that. Cool. Bind down to self.down. All right. And what does it do? Nothing for now. Okay. How about we will add logic to this. Let's see. We have our active piece. We should probably do something like this. If not, self.piece is active. Return. So if there's no piece that we can move, don't try to do anything. So we will have an active piece at some point. Spawn and set it to active. Okay. And we don't have anywhere that's setting anything to a piece being inactive. Self.piece is active is never false so far yet, because we haven't written the settle method. Well, we have this, but it doesn't do anything. It's never going to happen yet. We have active piece, and we will need that. How does it know where it is the question. I think it should have, should the active piece be a class that has a shape and these things, and not yet. Maybe a dictionary at the very least. I don't know. I'll probably end up having a class in there. I don't know. Shape is this. Piece is that. And piece. Okay. And row is 0 to start out. And then we can just increment that. Okay. Okay. So we will do the top row corresponding to this piece in the board will be blank in that area. Board self.active piece row and where is it? It needs to store that too. Start. How about column is start. Row column no board self.active piece row self.active piece column to the active piece's first row's length. Active piece column plus R equals this. C equals that. C to C plus active piece shape zero, and that's the length of it, right? I believe. Shape 0. Yeah, shape 0. Okay. C plus W. Board. We access the proper row of the board for the row, and then we have the proper column, 2 column plus width. Equals this times delete. Okay. Okay. I'm using list multiplication at the moment because it's okay when you have immutable objects in the list that you're multiplying. If you have mutable objects, like this, for example, then they would all be references to the same one. We do not want that. Okay, and then we will move down. So we've set the top row to be empty in the board. For, let's say, we'll increase the row. Active piece row plus equal 1. And r plus equal 1, so we can still do that. For row in range, r, what's the length? To the length r plus length of the self.active piece's shape. So we're starting at the new first row of the piece, and we're going to that row plus however many rows there are. And we can use column to good effect here. Self.board, and we'll need to reconfigure all the visual stuff. Self.board, row, let's just use, row, and then the column. So this is which row we're on, and then the column is C to C plus W. C to C plus W equals the first row index and row and whatever. No, this row is no longer the same, but we do need a 0 somewhere. Enumerate arrange? That sounds really dumb. Zip two things together. Let's for I row in zip range W and range this. Okay, I think that's better. So we have a range of, no, we need the length of the thing. We're already doing that. That's the length. Okay, what numbers do we actually need? We need which row it's on of the board and which row of the piece it's on. So if we zip the piece with a range of the board, for squares and row, so we have the actual row of the shape and a range of values because we'll be replacing things. So we need row for a certain predetermined length, distance, something, and that is going to be squares. Okay. How many columns is this? 105. It's a little long. 120 would be out to here-ish. I think this is okay. Maybe not. I don't know. Let's do this. This and that. Great. Okay. And then we have to change the visual representation, meaning the canvas stuff. Each piece just has to move down by some amount. And the active piece has the piece itself. So we're going to go through each piece and reconfigure it. And reconfiguring child objects on a canvas means for square in this is actually for ID in self.activePiece piece, is it? Yeah, for ID and active piece, because each of these things, the canvas.createRectangle method returns integers for IDs. For each ID in there, self.canvas item config ID how do I do that again? Let me look it up. Canvas item config move and chords right. It's actually the chords thing. New XY to change coordinates. List of coordinate pairs. Okay. How do I retrieve them? I don't know. I need the coordinates. That's slightly inconvenient. I will simply store them somewhere. Column chords something. No, the piece will have many groups of stuff. I can zip them. Okay. coords will be something. So we're appending to the piece, and we also want to append to the coords. All this stuff. Okay. Actually, we can move this over here. Hang on. Append this. It's also active piece dot append, whatever. Okay. We can move this up here. And then we can say this should be self.activePiece coords. And I think it can handle either a tuple, a for tuple of stuff, or just 4 arguments. YouTube is now telling me, please check the video resolution. The current resolution is 1920 by 1080, which is not optimal. What is that supposed to mean? I don't know. It thinks HD isn't optimal. So, okay then. Great, fine. We've got this. Create rectangle out of, coords, the last one. Okay. We append that. We append the coordinates and then use them. Okay. For ID coords in, we're going to zip. The piece has IDs, and the coords are the coordinates. We need x, y, x1, y1, x2, y2, x1, y1, x2, y2 equals coords. ID, and it's the coords method. X1 and Y1 and Y2 will move down. X1, Y1 minus, what do I call it? Self.square width. X2, Y2, this is plus. Plus self.square width. That should work, and YouTube is showing green again, so that's great. If no active piece, return. If self.activePiece with row, column, width of this, about L equals, great. Where else are we doing len? This is just L now. we're missing a syntax something. Zip all this. Okay, great. Range that to R plus L. This should be easier to read at the very least. Zip the shape and range for R and R plus L. Okay. Very good. If R plus L is how will we do that? Greater than self dot board height. We'll have other checks for now. If R plus L is greater than or equal to self.board height, we will also return. I want to see what this does. I want to see. Okay. Takes 1, but 2 we're given. Oh, there's a, yeah. We got. When you click a button in TK Enter, it does not send the click event, but when you press a keyboard button that has been bound, or you click on the canvas with a bound event, then it sends the event, meaning which key you pressed or where you clicked on the canvas, etc. So this is the easiest way to take care of that. Now we can call down with a keyboard press, or by ticking and just not setting an event because we're not using it. Let's try that again. Okay. Down, board not defined. Because it's self.board. Let's try that again. We have a piece. It only does it once. But it did it once. I don't know why it's not doing it again. Because I didn't change the coordinates. That's right. Okay. But we have something. I just need to do more things. All right. That's cool. I will add that. I will need to change the coordinates. Chords index. Okay, not exactly what I wanted to do. Active piece, chords index. Y1 plus equals self dot square width. Y2 plus equals self dot square width. And Y1, Y2. So we access the active piece coordinates by the index. It needs an additional access it by the index, increase. And this is just a tuple. So now self.active piece chord index equals x1 y1 x2 y2, and now this can just be active piece chords index. Will that work? I think that'll work. Extract them, increase, put it back, and then do this for each square of the tetrimino. Okay, let's run that and see what I did wrong. That's fine. Range. Okay. Save. Try again. Zip argument number 2 must support iteration. That's because I just had a length. That's an integer. I need a range object out of the integer. So do this. Next piece. Move down. I can keep moving it down. Oh my god. And now I can't because it's at the bottom. So that works. It's not going to spawn another piece because it hasn't settled. I just can't move it down anymore. This should be settle. Self.settle. Yeah. So it moves down, and there's going to be a whole bunch of conditions over here, but it's going to be settle, and we will have settle. It will also print clonk. How about? Let's close that. Let's run this. Have a piece. Now watch the birdie. List index out of range, and it said clonk. It didn't do this last time. Oh, it has to return also. It doesn't just return. Self.settle and return. Okay. Yeah. Make a piece. Down we go. And clonk. So that's cool. So the reason I have if r plus l greater than or equal to self.board height, and this, it'll be, I will explain further later, but the reason I'm doing this is notice that it moved down to the very bottom of the board and didn't say clonk, but then I hit down once again and then it goes clonk. So this means your piece moves down, and you can still move it around, slide it, kind of. And then the next tick, it will go clonk and it will settle. And I'll extend that to, hitting other pieces, because it's not necessarily going to be the bottom of the board. And should down and shift all be I'm wondering whether I should just have this do everything. No, because this goes by row. Would I just use column instead? Okay, this would all be the same. This would be greater than or equal to the width, or less than 0. meaning 0 less than or equal to r plus, no, start plus c or something. Yeah, c. It would be 0 less than or equal to c. I would need an or. 0 less than or equal to c, or c plus w greater than or equal to the width of the board. Because the piece doesn't have a width of 0, so it's not, you have to account for one side being too close or the other side being too close. This would all be the same. This would be a little different. Going for 51 minutes, and I've added a cool feature. Oh, you can't see it at the bottom there. It's at the bottom. There we go. Now we'll close that. So r plus equal 1, this would be basically, this is because it's moving down, and this is because it's moving down, so this part would be different. I think the checks might be different, and there would be no settle for sure. So this part would be different. This different. Not totally different appearance, but just there would need to be changes. Just checking different things, like which variable are we putting in, sort of stuff. Not totally different logic. We're going to zip the shape and the thing. So this is change the row, and then we just say change the board as needed. This would be the same, I think, for ID and chords index. And zip this. This would be different because we wouldn't be changing the y, we'd be changing the x coordinates. But on the whole, pretty similar. How do we retrieve the key? Keyboard event. What are all the possible event specifiers? Event specifier. Yeah, I would like to know what that is. Event dot something. Event dot widget. Event dot x. Event dot y. What else is there? Because I'm sure there's a which key you pressed event. We can do this. That's easy peasy sauce. Easy peasy. Did it print an error? Because I had no, that's not an error. Okay. Care delta height keycode keysim num serial state time type widget width x root y root. I think it would be, let's see, char keycode and keysim num. Print event no, not event. Print char and event.char and keycode and keysim and keysim num. Okay, let's close that. Let's do this, and let's do that. So the char is nothing. The keycode is 40. The keysim is down. That's familiar. Oh, there's someone in chat. Mandusan Chandrabose says, "One watching, hello. Say my name, please. Say my name, Bob Bacon. Please, anyone online? Yes. You just got here. Okay. Cool. 9:36. Yes. 9:36. Cool. Yes. I am checking on chat occasionally, and now I see that we have a visitor. Anyway, yes, hello. We're writing Tetris and checking what sort of attributes an event has. So I think we will use the keysim because the char is nothing, apparently. There's no character for the down arrow. The key code is 40. The keysim num is 65364. But the keysim down is familiar. So we can do that. Let me do this. You can see down. Okay, cool. So we're going to use the keysim. We can delete this. We can take out that. And oh, he's gone. Okay. There isn't any sort of notification noise for chat. All that happens is new messages appear, so I have to manually look over now and again. It's not it requires polling. It's not a push notification, so if you don't get a response within a few seconds, stick around, especially because there's a bit of a delay, like 30 seconds ish. I mean delay like video stream delay, so I will say something and then you'll only see it 20 or 30 seconds later. Mildly entertaining, I guess. If let's do actually I think we'll add this next time. Use event dot tsim to check event/direction. Okay. So that'll be for next time. So I've been going for over an hour. That is enough. And tomorrow, I don't know if I'll do more of this. It's kind of exciting. And maybe a game. I don't really know yet. Whatever I feel like. So thanks for joining me in chat briefly, Manu-san. And if you're watching this in the archive, remember to like, comment, and subscribe. I think there's other actions now. I don't remember. Share, I think. I don't know. Like, comment, share, subscribe. Do activities related to this video. I don't know. So thanks again, and I will see you next time. Have a good one.